Yo, 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 what's up, It's your I messed up. Hey guys, today we are gonna do 5-7, the Binomial Theorem. So, you will be able to expand using Pascal's triangle, and you will be able to use the Binomial Theorem. So, you can use the pattern of coefficients and the pattern of our exponents to write the expansion of a binomial. So if normally we had a plus b to the third power, we would do the distributive property and multiply all three of the binomials to get a cubed plus 3a squared times b plus 3ab squared plus b cubed. So to expand the power of a binomial in general, we first multiply as needed, and then we write the polynomial in standard form. So just take a look at these expanded forms of our polynomials. So we have a plus b to the 0 power is 1. A plus b to the first power is 1a to the first power plus 1b to the first power. Then we have a plus b to the second power. We have 1a squared plus 2ab plus 1b squared. So here what we're seeing is a relationship between the coefficients and the term and the power of our binomials. So the coefficients only column matches the numbers in Pascal's triangle. And this Pascal's triangle is named after the French mathematician, and it is a triangular array of numbers in which the first and last number of each row is 1. So we can see on every row, the first and the last number is 1, and every other one of the numbers in the row is the sum of the two numbers above it. So we always start with 1, then we have 1, 1, because we start and end with 1. We start with 1, and then we add 1 plus 1 to get 2, and then we end with 1. Then in our next row, we have start with 1, then we add 1 plus 2 to get 3, and 2 plus 1 to get 3. And then we end with 1. Once again, start with 1. 1 plus 3 equals 4. 3 plus 3 equals 6. 3 plus 1 equals 4. End with 1. And so on. So that's how you get the following row. We can use these in order to expand our binomial. So using Pascal's triangle, what is the expansion of a plus b to the 6th power? So we are I'm going to cover this and do it step by step with you. So what you want to do first is write out Pascal's triangle. We have 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. This first row is our 0 row. Since we are raising it to the power of 6, we want to go to the 6th row. So this is row 0, row 1, row 2, row 3, row 4, row 5, and row 6. So this is the row that's important to us. We're going to start by writing out those coefficients. Sorry, I just wanted to shrink my coefficients. So we want to be focused on the numbers 1. Oh, my Lord. Okay, let's try this again. 1, 6, 15, 20, 15, 6, and 1. Then we are going to look at our terms, our first term in our binomial and our second term in our binomial. Our first term is going to start at the power we're raising our binomial to and go to 0. So we're going to start with a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, a to the 0. And our second binomial is going to start with the 0 power. So it's going to be b to the 0, b to the 1st, b to the 2nd, b to the 3rd, to the 4th, 5th, and go up to the power we're raising the binomial to. So it's going to go from 0 to 6. And since we have a positive sign, we're going to be adding all of these. Then just simplify. B to the 0 is 1. A to the 6th times 1 is a to the 6th. Plus 6. A to the 5th, b. Plus 15. A to the 4th, b to the 2nd. Plus 20. A to the 3rd, b to the 3rd. Plus 15a squared, b to the 4th. Plus 6a, b to the 5th. Plus b to the 6th. So notice how our first term's exponents are going towards 0, and our second term's exponents are going towards the power, or 6. So the binomial theorem gives us a general formula for expanding binomials. For every positive integer n, a binomial raised to that power is what we just did using Pascal's triangle. Let's expand this binomial as well. We are going to use the 5th row of Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1 would be our 5th row for coefficients. 1, 5, 10, 10, 5, 1. We know that our first term starts with our exponent. So we have 3x to the 5th, 3x to the 4th, 3x to the 3rd, 3x squared. Oh, I skipped a coefficient, sorry. 1 would be my first coefficient, so it should be 3x to the 5th, to the 4th, 3rd, 2nd, 1st, 3x to the 0. Now we're going to take negative 2. And we are going to put negative 2 raised to those powers. So it's going to be negative 2 to the 0, negative 2 to the 1st, negative 2 to the 2nd, negative 2 to the 3rd, negative 2 to the 4th, negative 2 to the 5th. And then simplify. We're not going to put signs because the negative is either going to give me the term's sign. So it's either going to be positive or negative. Anything to the 0 power is 1. 3 to the 5th power, or 3x to the 5th power, I'm sorry, means we have to take 3 to the 5th power times x to the 5th power to get 243x to the 5th. Now we're going to have negative 2 to the 1st, which is negative 2, 3 to the 4th, which is 81, times negative 2 times 5 is negative 810 x to the 4th. Now I'm going to do 10 times 3 to the 3rd times negative 2 to the 2nd. Negative 2 squared is positive 4, so then I get plus 1080 x cubed. Do the same thing, 10 times 3 to the 2nd times 2 to the 3rd minus 720 x squared, 5 times 3 times 2 to the negative 2 to the 4th is plus 240 x. 3x to the 0 is 1. Negative 2 to the 5th power is negative 32. So this is our binomial expanded. You guys try these two and we are done.